Thank you for the presentation. Good morning. I'm Silvia Perez, and I work in a group of radiation physics and environment in the university, from the University of Huelva, and it's in the southwest of Spain. And the title of my work is Potential Valorization of Artificial Gypsum Generated in the Manufacture of Titanium Dioxide Pigment. So I will begin with a brief introduction of the problem treated in this work and the main objective set out. After I present the material studied and the method used, and followed by the application used, and the final remark or the final conclusion. So, globally, huge amount of inorganic industrial wastes are generated in the managed represent a high cost and an environmental problem. So, in this sense, the development of technology and new application to valorize these wastes is of increasing importance. In southwest of Spain, in Huelva, there is an industry that is engaged in the production of titanium dioxide. This industry, you can see in the picture, generate two residues, red gypsum and an attack almanite matte that have been studied in this work. This titanium dioxide is a pigment that delivers whiteness to a vast range to a lot of products. So in this slide, I present the industrial process. You can see that the raw material is the ilmenite that is digested with sulfuric acid. After a clarification step, it is generate the matte. Is the first residue that have this industry. The titanium dioxide is produced after a precipitation, filtering and washing and calcination step. During the wash step, it is generated the weak acid stream that after a neutralization with calcium hydroxide, it is generated the red gypsum. Large amount of these wastes are produced. About 30,000 tons per year of matte and 70 tons per year of red gypsum. Currently, these wastes have no commercial value and are disposed of in an authorized and controlled repository area. So the objective set out in this work is use the red gypsum and matte as building material for fire-resistant panel. And the second objective is use of red gypsum as calcium source for carbon dioxide sequestration. In order to characterization the weights and new products, the analysis technique used was X-ray fluorescence, X-ray diffraction, inductively coupled plus mass spectrometry, granulometry analysis, thermogravimetric analysis, and scanning electron microscopy. Matte and red gypsum samples were collected every 5 days for 1 month in order to evaluate the possible temporal variability of the characteristics of this material. And in order to carry out the application study, In this work, several materials as pladur, vermiculite, and sodium hydroxide were used. So in next slide, I will present the characterization of this waste in order to understand the application selected. And following by I explain the experimental procedure of each application. So, mud is the insoluble solid fraction of ilmenite in sulfuric acid. So, mud is composed mainly by titanium, iron, and silica. According to mineralogy composition, it's composed of ilmenite, rutile, zircon, and quartz. These phases are highly refractory. In this picture, you can see the particle number 1 is a zircon particle. 2 and 3 is a silicon particle, and number 4 is the ilmenite particle. Red gypsum is generated in the neutralization of the weak acid stream with calcium hydroxide, and it is composed of calcium mainly, and sulfur, iron, and titanium. According to the mineralogy composition, it's composed of gypsum and iron and titanium oxide. In this picture, you can see the characteristic morphology of gypsum, and the number 3 is the amorphous phase with high content of titanium and iron. So I will explain the first application that is red gypsum and mud as building material for fire-resistant panel. For this application, it was manufactured 3 plates. The plate 1 is with red gypsum, 100%. Plate 2 with red gypsum, 75% and 25% of mud. And plate 3, 80% of red gypsum and 15% of mud and 5% of vermiculite. Vermiculite was used to increase the insulation capacity of plates, and this plate was compared with a pladur that is used as typical building material. Plates were made using a low-cost manufacturing method. The components were mixed with water in different percentage, and the pastes obtained were put into a mold and were dried for 25 days at ambient temperature. The fire-resistant capacity was evaluated in agreement to EN 30631 standard, which established a temperature versus the time inside an oven by this equation. In this figure is shown the result. In the right axis is represented the temperature spoke side, and in the left axis is the temperature on spoke side versus time. This line belongs to pladur, and you can see that reach high temperature in short time. whereas the different plates need more time to reach the same temperature. So plate 1 and 3 have similar insulation behavior, much better than pladur. But plate 2 and plate 3 have a slightly better behavior. It's because the addition of mud, the first weight, improves thermal insulation significantly, mainly due to its high light refractory mineral phases. However, the influence of vermiculite on the material was negligible. In order to evaluate the environmental impact, it was studied the mobility of pollutant of different plates. And you can see that the metal are lower than the regularity limit for the TCLP test. In next slide, I explain the second application with red gypsum. And in this case, red gypsum was used as a calcium source for carbon dioxide sequestration. The carbonation process involved the extraction of calcium using a sodium hydroxide solution, and followed by the reaction with carbon dioxide in aqueous phase in this condition. And after, the product was separated by filtration. This is the reaction that it takes place. You can see that the products generated are calcium carbonate and sodium sulfate. Calcium carbonate in solid phase and sodium sulfate in solution. So both products were studied, and in this slide I present the concentration of major element and the transfer factor. And you can see that the main component of red gypsum, calcium, titanium, and iron, remain in the carbonation fraction. But the sulfur and sodium are transferred to the sulfate fraction or solution fraction. Other techniques was used to characterization of carbonated fraction. And the main component is calcite and rutile. In this image, you can see that the particles present are poorly developed rectangular shape, which is characteristic of calcite. The titanium and iron remain in these phases undisturbed. In order to evaluate the degree of carbonation of these residues, it was calculated the carbon dioxide sequestration efficiency. It is defined by relation between the calcium in form of carbonate generated in the process and the total calcium in the rich gypsum. The result is presented that it is shown that the red gypsum had a high degree of carbonation, and the uncertainty is very low, so the carbonation fraction process with red gypsum is reproducible. So in the next slide, I will present the main conclusion for each application used. In the first one, fire-resistant tests demonstrate that the plates perform better than some material used in construction, such as pladur. The tested material also possesses acceptable mechanical property that show no noticeable distortion or breakage during the test, although the mechanical property of plate must be studied. Also, it was conducted leaching tests using the DCLP procedure, and results show a negligible environmental impact. In the second application, where is used the red gypsum as a calcium source for carbon dioxide sequestration, the product of carbonation using a solution of sodium hydroxide is mainly calcium carbonate and sodium sulfate. The pollutant remain almost completely into the carbonation fraction, whereas the sulfate fraction is very clean. The environmental implications of both of them are negligible for future application. And the carbon efficiency obtained is very high under experimental conditions. And as final remark, this study was carried out to evaluate the use of red gypsum as building material for fire-resistant panel and a calcium source for carbon dioxide sequestration, owing to its high content of calcium. Previously, it was necessary an exhaustive characterization of raw material, and later a study of new material obtained or product was made. Preliminary results show that these residues are viable in the studied application, and the environmental implications are considered as negligible. Thank you for your attention.
So thank you very much. And any comments and questions? Okay.
Very nice presentation.
Thank you.
You have presented here the live case study of the reuse of waste.
Sorry, if you speak slowly, I can't understand you. Sorry.
Okay. Miss, it was a nice presentation. You have presented a live case study of reuse of industrial waste. But you are talking about here the environmental aspect is nothing is there. But you are not tell us about the economic aspect. Means
Yeah.
how it will be profitable to the society if they will go for the recycling of this kind of waste.
Okay.
Are you got it my question?
Yeah. Well, the economic aspect, it not was evaluated exactly, okay? Because we were studying the possibility of use this residue to something to avoid dispose this waste in the soil. So it is an aspect that I will be considered, but in the same in both applications, the procedure are very easily, and it's not expected very expensive cost. okay? Because in one application was a simple mix in simple condition, and in the second one application was in temperature room and pressure atmosphere, so it's very easy, and I would expect it's very cheap procedure.
Thank you.
Thank you.